So we have started numerical analysis course. That I have told you that this course we are studying when we do not have any exact solution for some problem, right? Then we go for the approximate solution that will be close to the exact solution. So for that, what we have discussed the floating point representation. Floating point representation. What we have done, if we have any number x, we can represent it in the floating point representation like this. This is 0.a1, a2 and so on, right? Into 10 raised to the power e. Because we are dealing with the decimal number in this course, so I am taking the base over here as 10 and e is your exponent, and all these ai's are integers. So this is equal, the sign here we consider plus and minus. If it is positive, we will consider positive sign. If it is negative, we will consider negative sign. Since ai's are integers and we are considering negative sign over here, so what will be the range of ai? ai's are integers and I am considering negative number over here. So it will lie between 0 to 9, right? Then what we have done, after this, we have done the normal form of floating point representation, in which what we did, that the mantissa part should lie between from -1 to 0.1. That means if I have a1 can't be 0. If it will be 0, it is not in the normal form. And we have done 2 or 3 remarks that the floating point representation of a number is not unique. You can represent any number 0.483 into 10 raised to the power 2. This is the one way. You can also write this number as 0.0483. This way you can write, so floating point representation is not unique. Is it clear? Yes or no? Any doubt till here? That we have, in every lecture, I'll give you just a quick review what we have done in the last lecture so that you can do the correlation, what we are going to do now. Now, since we are using the computers to store the numbers, so computer has limited space. So there are 2 ways to store the number. That the numbers either can be chopped, that is the procedure of chopping and rounding. So if x is your number, is any real number, then to store this number, then to store the number, computer has limited space. So the number is to be approximated one. So the number is the approximated number. Like you do that your pi is your 22/7. Sometimes some computers can take only 16 digits, but it is never ending digit. That means when you store that number in the computer, that is the approximated number, but not the exact number. Exact number is 22/7, but you can't store that fraction part in computers. So the number that you store, that will be the approximated one. So that I have told you that when the number is to be approximated, we will do in these two types, that is chopping and rounding. So firstly, I am telling you for chopping. Let x be any real number and FLX be its machine approximation. Here FLX means I am using the floating point representation of a number, right? This FLX means I am using the floating point representation of a number. Is the machine approximation then in chopping, FLX will be is equal to plus minus 0.A1, A2, chopping up to AN or N digits. So the floating point representation, if I'll consider only N digits, this will be this. The numbers which are greater than will be your AN, that will be deleted, and up to you will cut your number up to your AN. For example, if you have any number 0.8143 and you have to consider only 3 decimal places, so what you will do? That means you need only 3 places after your decimal. So the floating point representation of the number up to your 3 digits, that will be your 0.814 into 10 raised to the power 3. Is it clear? Yes or no? That means you will delete all those digits that will be after your 3 digits. Is it clear? Even if your number is like this 818147 into 10 raised to the power 3 and you have to chop it up to your 3 decimal places, the number will remain same. So you can see from here, like we are doing the approximation, error is already occurred over here. So when you have to store a number, the number was actually your 0.8143 into 10 raised to the power 3. But because the computer can take only the 3 digits, right? So that means that number is stored as 0.814. Even on that place, on place of 3, if it is 7, 9, 8, any number, it will consider that as your 0.814. So that means error has occurred. And this is your approximation, not your exact number, right? So this is the case of your chopping. And in case of rounding, the rest, the definition is same. You have X any real number and FLX beats machine approximation. Then in rounding up to AN or N digits, the representation of FLX will be the representation of, that means the approximated number will be 0.A1A2 AN, because you have to store only N digits. If your AN is less than 5, and it will be your 0.A1A2, and your nth place you will add 1. If your AN, sorry, an plus 1 is less than 5 and your an plus 1 is greater than equal to 5. In some books, when you will read local books and some books, you will read definition that for n is equal to 5, they consider two different cases. That the n plus 1th place should be even and odd. But nowadays, the computer is using only this. When your an plus 1 is greater than equal to 5, it will add 1 to your nth place, right? So for this course, when you are doing rounding, don't follow that procedure कि आपकी an plus 1 odd है, even है. You don't consider, you just consider that your an plus 1 digit is 5, or if it will be greater than 5, then you will add 1 to your nth place. The same example for rounding case, it will be that you have 0.8143 and you have to round off this number up to 3 digits. So what will be its rounded off number? That is the same as the chopping, because here at my fourth place, the number is less than 5. So it will be 0.814 into 10 raised to the power 3 in case of rounding. And if the number is 0.8147 into 10 raised to the power 3, and you have to round off this number up to 3 decimal places, then the number will be rounded off 0.81. Now you will tell me its solution. If a number has 139 and I only want 2 digits, what will be the rounding and what will be the chopping? If you have any number, this 139, and computer can store only 2 digits, not a 3-digit number. So what will be its rounding and chopping? The best way, if you can't see ki kitne digits le, because sometimes you have read 0 significant digit and that should not consider. Convert this number into the floating point representation. If you write its floating point representation, क्या होगी इसकी floating point representation? 0.139 into 10 raised to the power 3. Now can you round off or chop? So when you will approximate this number for chopping up to only 2 digits, what will be the answer? I want only 2 digits and all other digits will be neglected. Either it will be greater than 4 or greater than 5 or not. So it will be your 0.13. And in case of your rounding, it is 0.14 into 10 raised to the power 3 into 10 raised to the power 3. So that means the number when you will store in the computer, it will be 130 for chopping and it will be 140 for rounding. Is it clear? So you can see from here, don't consider when I'll tell you the definition of significant digits that 0 is a significant digit or not. So 0 is a significant digit, right? But when you have to round off and when you will convert it into the floating point representation, you get the answer. Or from here, you can also see this is your n plus 1th place. And n plus 1th place, it has the digit which is greater than 5. So for rounding, it will add 1 to your nth place. And for your chopping, it will cut digit. जब digit cut करोगे तो इस तरह से नहीं लिख देना 13 and 14. The answer will be wrong. Because exact answer it will store, that is your 130, 140. Remember this thing that you have to insert 0 in the end if it is a complete number, that is your whole number, right? Any doubt till here? Any doubt? So suppose if you have any numbers, x is your any number, 0 point, suppose I am taking 8153 into 10 raised to the power 4, and y is your number 0.0873 into 10 raised to the power 2. When you have to do the arithmetic operations, when you have to do x plus y, now I'm not talking about the approximation or not, right? I'm not considering any approximation that you can store in the computer. I'm talking about the exact value, right? So how you can add this? Since it has a base 10, both have base 10, but the exponent for this is your 4, and for the exponent for this is your 2. So if your exponent is not same, you can't do the operation of plus and minus. That is, you can't do addition and subtraction. So how you will add? The number which will have less exponent, you will make that exponent equal to the greater one. So it has 2 exponent and the difference is 2. So this number will be your 0.000873 into 10 raised to the power 4, and this number will remain same, 0.8153 into 10 raised to the power 4. Any doubt till here? So when you are finding the exact value, when you will do x plus y, so you will get the answer, that is your 0.816173 into 10 raised to the power 4. And when you will do the subtraction x minus y, that will be your 0.814427 into your 10 raised to the power 4. When you have to multiply, you just multiply the numbers. क्या करते हो multiply में? When you have same base, the powers will get add. So simply you will just multiply 0.8153 into your 0.00087, or you can say 0.873 into 10 raised to the power 4 plus 2. Is it clear? Then you need not to convert the number into the same exponent, right? You can just multiply it like that. X by y, what you will do? 0.8153 will be divided it by 0.0873, and the base will be same and the powers will be subtracted. Only in case of addition and subtraction, you have to make the exponent equal. Is it clear? There is no need to make the exponent equal for the case of your multiplication and your division. Clear? So now these are the basic operations. And suppose I am taking that computer can store only up to 4 decimal places. So computer can store only 4 decimal places. So when you will take x, x will remain same because it has already 4 decimal places. And when you will consider y, and 4 decimal places with rounding I am taking. What will be y stored in your computer if you have 4 decimal places rounding? And you have to perform the operation x plus y and x minus y. You computer can take only 4 decimal places. That means when you have to add, the power should be same. So that means for making the power should be same, but your y will be stored. That is 0.0009, because for rounding and 8 will be for your chopping. So you can see from here that your actual number was 0.0873 into 10 raised to the power 2, but it has stored 0.0009 into 10 raised to the power 4. So error has occurred. That means when you will perform the operation of x star plus y star also, so when there will be a question in further examples also that you have to do rounding, 2-digit rounding, 3-digit rounding, or 4 decimal place rounding, you have to do rounding at each and every step. कि अगर जैसे पहले आपका नंबर 0.8153 था, आप क्या करते, पहले आप मल्टीप्लाई कर देते, फिर आप उसको राउंड ऑफ करते, दैट विल बी योर रॉन्ग, because computer will do rounding at each and every step. That means you have to do rounding or chopping manually yourself for performing the operations, right? So when you will do x star plus y star, so the answer will come out to be your 0. And x star minus y star will be your 0.8144 into 10 raised to the power 4. Like now you are storing a number in a computer, and again you can see that there will be some error, right? So how to deal with this error? How much you can satisfy yourself that I am satisfied with the answer? We do the measures of errors. We will do the measures of errors. You can satisfy either if you will take the absolute error, absolute error is if you have any value, if x is any real number and FLX be its approximation, then the absolute error we denote it by, and this is the difference, absolute difference of x minus FLX. That is the floating point representation. This is known as your absolute error. And the next is relative error. The same definition, if x is any real number and you are using its approximation, then the relative error in that case will be your ER, and that is the modulus of x minus the approximation divided by its actual value. This will be your relative error. Next is your percentage relative error. That we will denote it by EP. This is x minus approximation divided by its actual into. That means this is relative error because we are dealing with the percentage. Clear? These are the measures that when you will do questions in numerical, when you will find the value, that you have to satisfy that if your absolute error, if it will say that the absolute error is less than suppose 10 raised to the power minus 5, then you can stop. They can also say that if the relative error is less than 10 raised to the power minus 5, then you can stop. Then you can also go for the percentage error, right? So for this can be the stopping criteria, that how you can stop at some iteration. Is it clear? So because I'll consider one example after this. The relative error, the measure of relative error is better than your absolute error, that we will follow from your this example. So if you have example, let P is your any number 0.3000 into 10 raised to the power 1 and its approximation be so calculate the absolute error, and the question can be the calculate the absolute error and relative error for these problems. So the first part is now P is your 0.300 into 10 raised to the power 1 and this is the case. So that means when you have to find the absolute error, your absolute error is P minus the approximation of P, that will be your 0.300 into 10 raised to the power 1 minus this, and this will come out to be your 0.0100, and if you write it into the standard form, this will be this. And in case of relative error, if you find, this will come out to be your 0.3333, so on, into 10 raised to the power minus 1. This is for the first case. And if you consider the second part, the absolute error in case of second part is coming out to be your 0.1 into 10 raised to the power minus 4. And your relative error is coming out to be your 0.3333 into 10 raised to the power minus 1. And in case of third part, your absolute error is coming out to be your 0.1 into 10 raised to the power. It is not minus 4, it is 4. And your relative error is coming out to be your 0.33. 0.33 into 10 raised to the power minus 1. So here you can see that your absolute error is always coming out to be your 0.100. It is changing with respect to the position. But your relative error is considering the position as well. So you can write over here, relative error here relative error is 0.3333 into 10 raised to the power minus 1. यहाँ पे आपका एब्सोल्यूट एरर आया 0.100 10 raised to the power 0. The same you get, the relative error is 0.333 10 raised to the power minus 1. In this example also you got the same error, but your relative error is varying widely, right? That means it is considering the position as well, but your relative error is remaining same. However, only the position is changed, the number is same. That is 0.3000, 0.31100. So that means your relative error is better than your, that means the measure of the relative error that you consider, that will be your better than your absolute error. So you can write one remark over here. As a measure of accuracy, The absolute error may be misleading and the relative error is more meaningful because the relative error takes into consideration the size of the value as well. So the examples which we have discussed before, that we have taken X and Y, right? You can find the absolute error and relative error for the same. Clear? Next example is that find the largest interval. Find the largest interval in which FLX, that is floating point representation of X, must lie to approximate under root 2 with relative error at most 10 raised to the power minus 5 for each value of X. So now the question is that you have to find the interval. आपको सबसे ज्यादा लार्जेस्ट इंटरवल निकालना है so that you can approximate under root 2 और आपका एरर ज्यादा से ज्यादा कितना हो 10 raised to the power minus 5. Now because you have to approximate under root 2, that means your actual number is your under root 2 and FLX you have to find, right? And the one condition उन्होंने क्या दिया हुआ है कि आपका relative error ज्यादा से ज्यादा कितना होना चाहिए 10 raised to the power minus 5. So that means here your relative error should be less than or greater than? Less than equal to 10 raised to the power minus 5. Just apply the definition of relative error x minus FLX divide by its actual value x, that will be less than 10 raised to the power minus 5. So it will be your root 2 minus FLX that you have to find, divide by root 2. This is less than equal to 10 raised to the power minus 5. Root 2 is a positive quantity. Can I take it out from the modulus? Yes. So it will be your root 2 minus FLX. If I'll take it out from the modulus and shifting, multiplying with root 2, it will be your root 2 into 10 raised to the power minus 5, right? You have done the property that if you have mod of X is less than equal to A, then A lies between minus A to A. So for this case, your this thing is lying less than equal to root 2 10 raised to the power minus 5. That means it lies between clear up to here. Now you have to find the value of FLX. You have inequality that it root 2 over here. So what you can do? You can subtract root 2 from the inequality. So what it will be? That will be minus root 2 into 10 raised to the power minus 5. That will be less than equal to minus FLX, that is the approximation. Any doubt till here? Yes or no? No. So this FLX, now you got the range, but this FLX is negative. So when you will multiply with the negative sign, what will happen? Inequality sign will get changed. So when you will multiply with the negative sign, this will be your root 2 plus root 2 into 10 raised to the power minus 5. That will be greater than equal to FLX and greater than equal to root 2 minus. So the interval, when you will solve this, you will get the interval. So in this interval, only if you will approximate under root 2 in this interval, then you can get the relative error at most your 10 raised to the power minus 5. Is it clear? The error can be more or less, but it will not be greater than 10 raised to the power minus 5. Okay? इसीलिए ही हम root 2 की approximation 1.414 consider करते हैं. ठीक है? Any doubt till here? Yes. Anybody having doubt till here? Next is quite boring part that you consider the theorems are always boring. But we can make it interesting. We can have interaction while doing the theorem part also. So the next theorem is for the chopping. That means what at most what error can be occur for approximating a number so that your relative error, the at most error for chopping and at most error for your relative case. So the same, if you have any number, let x is equal to any number plus minus that I am considering it in actual value, that is 10 raised to the power e, and FLX be its approximation up to n digits only. Then we have to find the relative error, at most relative error, and the absolute error in case of chopping. So firstly, we are doing for the absolute error because in the relative error, we just need to divide it by mod of x. There is no change after that. So when we consider x is my number, plus minus 0.a1, a2, an, the further digits can be an plus 1 and so on 10 raised to the power e. And your FLX, can I write this number like this? Can I write this number? Because A1, that will be point A1. When you will add a 0.00 A1, that will be point A1 and the same will be added. So this is plus minus. So I can write this as plus minus. It can be. I is varying from 1 to infinity. AI divided by 10 raised to the power I into 10 E. And if I am using its approximation in this form, what it will be? Yes, in the series form, what it will be? Summation form. This will be plus minus summation I is equal to 1 to summation I is equal to 1 to n, because we are considering chopping only up to n digits. So this will be AI 10 raised to the power I into this. Now when you will do the absolute error, that will be your x minus flx. क्या value आएगी? Because it is in the modulus, so you can ignore the plus minus sign, right? So what value it will give? I have a sum I is equal to 1 to infinity, ai 10 raised to the power I. Can I write like this? Yes or no? Because they have same 10 raised to the power e base, so that I have written it out because I have to just subtract the number that is in the mantissa part, right? So what the subtraction will be? क्या होगा? Yes. So the summation it will have I is equal to n plus 1 to infinity the digits which you are considering. When I have asked the range, what will be the range? तो क्या range आपने ली थी ai की mantissa part में? 0 to 9. That means every ai, each ai that will be less than equal to 9, right? That 9, can you write that is equal to 10 minus 1? That means if I'll use this here, so that means this equality that will be less than inequality. Summation I is equal to 1 to n plus 1 to infinity. That will be 10 minus 1. ठीक है, यहां तक कोई डाउट है? Now 10 minus 1 is independent of I. Can I take it out from the summation? Yes or no? 10 minus 1 is independent of I. I can take it out from the summation. So that will be 10 minus 1. And it is a positive part also. I can take it out from the modulus. This will be summation I is equal to when you will sum up something, जो मॉडुलस होगा वो कंसीडर करो या नहीं, कोई प्रॉब्लम होगी? Because you are summing up the positive things, that means this is equal to this, right? So can you see what is this? If I'll write like this, then you can, I think, this is 1 by 10, 1 by 10, n plus 1, n plus 2. This is nothing but your sum of GP. क्या होता है GP? S infinity A upon 1 minus R, and here R will be 1 by 10 and A will be your 1 by 10 raised to the power n plus 1. So when you will solve this 10 minus 1, this is 10 raised to the power E, and when you will solve this, you will get 10 raised to the power E minus n. That means your absolute error at most in case of chopping, that can be your 10 raised to the power E minus n. I'll do it for relative error, then I'll stop. Relative error is nothing, that is x minus flx. So that you can also do like this. This part you have already calculated, that this is less than equal to 10 raised to the power E minus n. Next is just you have to calculate mod of x. So now mod of x is your 0.A1, A2, an Here we consider the numbers in the normal standard form, normal form of the floating point representation. अगर ये normal form में है तो हर AI आपका किससे बड़ा है? If it is in the normal form, every AI will be किससे बड़ा होगा? 0 से बड़ा होगा. 0 से बड़ा होगा. That means AI किसके या तो 1 होगा या वो उससे बड़ा होगा. Is it clear? Because in the standard form of the floating point representation, you can't take A1 as 0, right? So that means अगर वो 0 नहीं है तो वो नंबर या तो आपका 1.1 से बड़ा होगा या वो आपके 0.2 से नंबर सारे क्या होंगे? छोटे. So that means this will be greater than equal to, बाकी हो जाए तब भी वो नंबर 0.1 से तो बड़ा ही रहेगा. If you have a number like this, any number, if you can take x is your 0.1003, तो मैं तो कह ही रही हूँ that is number is greater than 0.1. Here you can't take 0 because we are considering the normal form for the floating point. So whatever number this will be, in the standard form, it will be greater than equal to 0.1 into 10 raised to the power e. That is actually or equal to 10 raised to the power e minus 1. So when you will calculate the relative error, when you reciprocate it, 1 by mod of x will be less than equal to 1 by, inequality will get changed, right? So that means your relative error x minus flx by mod of x, this will be less than equal to 10 raised to the power e minus n, that you have calculated from the absolute error, divide by 10 raised to the power e minus 1, that is equal to 10 raised to the power 1 minus n. So that means for chopping, you will have the absolute error, at most absolute error, that will be 10 raised to the power e minus n, and your relative error, that will be your 10 raised to the power 1 minus n. Clear? Yes or no? Okay, thank you.